Hello, everybody. So we're going to go over the notes and definitions for this new chapter. Now, the new chapter is, it's called Angles and Transversals. So we're going to start off with just these 8 ideas, these 8 vocabulary words and phrases. So what I'd like to do is just kind of zoom in one box at a time, because we're going to use these notes for the next few examples. So let's just dive in here. So what I'm looking at here is basically a straight line, right? But we're going to call this a straight angle. Now, I want you to think of, a circle, right? So a circle has 360 degrees. So if we draw a line that splits it in half, well, then bottom half would be 180 degrees, top half would be 180 degrees. But if we are just looking at any line, what we're going to say is any straight line is a straight angle with a measure of, 180 degrees. So what I'm going to call this angle here is, I'm going to trace it from P to Q to R, okay? So I'm going to call this angle PQR. Now I could have also traced it in the opposite direction, so I could have called it angle RQP. Whichever name I call it, PQR or RQP, the measure of this straight line is 180 degrees. Okay, let's move on to the other box here. Now, I'm just going to spend only a couple seconds on this because this doesn't come up very often, but a zero angle is an angle that has 0 degrees, right? So if I could pretend that I have this ray here, right? A, and I'm going to put C. You'll see why I'm going to put B here in a minute. Whoops. So, for example, let's say I have another ray out here that is a straight line, right? So if it was a straight line, that would be 180 degrees. If I brought this angle up, it would be 90 degrees. And if I closed it all the way, that's what we're talking about here. If I close this all the way, then there's no angle or degrees between it. So that's what this is called. We call this a zero angle. So if I trace in this order, watch, from B to A back to C, there's no space or degrees in between there. So I'm going to call this angle BAC, or I could even reverse the letters and go from C to A back through B, right? But there would be 0 degrees or 0 space in between there. So we're going to say that is a zero angle. All right, now more importantly, I think the bottom of this page is what we need to worry about. So an adjacent angle is an angle that is, well, they say it's an angle with angles with a common ray. But what I want you to do is I just want you to write down also that these are angles that are connected or attached. Let's think of it that way as well. 2 angles that are side by side, connected or attached, like this one and this one. So these angles we would say are adjacent. But I'm going to think about it, the colors yellow and blue together make green. So watch, if I highlight this angle AOB, I just traced it in blue. If I trace the other angle below it, right, angle BOC in yellow, well, then the overlap, the part that's shared between them, kind of turns green, right? So basically, they're sharing or connected or touching at ray OB, right? This ray right here is ray OB. So here's what we're going to say. Adjacent angles are angles with a common ray, or are connected or attached. So adjacent angles here would be angle AOB, which was the one I highlighted in blue, and angle BOC, which I highlighted in yellow. Notice they have a common vertex as well, right? They have a common corner point. And it's also the middle letter of my angle, all right? And that's going to be, each time we write or draw the letters for an angle, the middle letter is going to be your vertex. All right, let's finish this up. Angles with a common ray, so angle AOB and angle BOC are adjacent angles because they share ray OB. Now here's how we draw the symbol for a ray, all right? It's got the arrow pointing in one direction only, just like O goes through B in one direction down in the diagram. All right, finally, we're going to write down that, actually this is a typo here, let's fix that. Let's make that a plus, please. So we're going to say that this angle plus this angle equals the whole thing, okay? I like to just refer to this as part plus part equals whole. So the measure of angle AOB plus the measure of angle BOC should be equal to the whole thing. And I'm going to call that angle AOC. So for example, if AOB was 40 degrees and angle BOC was 30 degrees, then the whole angle itself would be 70 degrees. Okay, cool. All right. Last couple here. So let's get to what vertical angles are. Now, vertical angles are equal angles that are across from one another. So I'm going to use yellow here, and I'm going to shade in angle 1. What is across from, or on the other side of angle 1, is angle 3. These angles will always be congruent or equal, right? So I'm going to say angle 1 will always be equal to 3 in this diagram. Also, let me grab blue, right? Because I'm going to highlight angle 4. And what's straight across from or equal to 4? Well, that's going to be angle 2 over here. All right, so whenever you have crisscrossing or intersecting lines like this, it's going to form 4 angles. And your angles across from or on opposite sides from each other, like 4 and 2 or 1 and 3, will always be equal to each other. They're called vertical angles. Okay. Complementary angles. 2 angles with a sum of 90 degrees. I like to always think about this diagram here. If you see a diagram like this, and usually there's a little right angle box there, well, take a look here. These 2 angle measures have a sum of 90 degrees. They add up to 90 degrees. Now, these 2 are complementary. They add up to 90. They're also adjacent because they're attached. They share that common ray. However, over here, these 2, well, 27 plus 63 is in fact 90 degrees. So yes, they're complementary, but they're not adjacent, right? They're separate, they're not attached. All right, and similarly over here, supplementary, right? So what I always usually think of for complementary, C comes before S in supplementary. So complementary belongs with 90, supplementary is 180, right? So alphabetically, C comes before S, numerically, 90 comes before 180. All righty, but the same rules apply here. Supplementary has a sum of 180 degrees. So 65 plus 115 is 180. These 2 angles are supplementary and they're also attached, which is adjacent. All right, and then lastly, over here, these are just supplementary because they add up to 180 degrees, but they are not attached or adjacent. All righty, last two. So this kind of piggybacks off of what we just said. We have angle 1 and angle 2. Now let's just suppose angle 1 was 50 degrees. Well, think about it. These 2 together are supplementary. So this linear pair has to add up to 180 degrees. So I would take 180 minus 50, and that would give me 130 degrees. Okay, so a linear pair is just a special case that has both of these things going on. Adjacent, which means they're attached, and supplementary, which means they add up to 180. Okay, so if I look at what they gave us from the beginning here, actually I'd like you to write this down. I'm going to say the measure of angle 1, right? I could use letters, but we could also say this is like the first angle and this is the second angle. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. All right, so in summary, a linear pair has to be attached and add up to 180 degrees. And guys, it's always going to look like this, this straight line that is split up into 2 pieces. Okay, and that brings us to our very last example here. I hope you're writing this all down. But it's an angle bisector, excuse me. So if something is bisected, the prefix bi meaning 2, tri meaning 3. So angle bisector means it's cut up into 2 equal pieces, right? A ray, a line, or a segment that divides an angle into 2 equal parts. So down here, I'm going to zoom in. I want you to notice this notation. They're using an arc and a dash, right? They're making the same symbol in each of those angles, which tells me, hey, this angle is the same as this one. All right, now, ready? Let's finish up and write and fill in our spaces below. It should say, now I'm going to use a highlighter. I want you to do the same. Okay, I'm going to highlight ray AB. Oops. So what I'm going to say down here is if ray AB, which I highlighted in blue, bisects the whole angle. So the whole angle is called angle CAD, right? So if ray AB bisects angle CAD, well, then it means it cuts it in halves, right? 2 equal pieces. So then which 2 angles are equal? Well, I'm going to say angle CAB and angle BAD are equal to each other, right? Because it's getting split in half. The whole angle is getting cut into two equal pieces. I'm also going to write down the bottom this whole idea that part plus part equals the whole thing, okay? So I'm going to now write angle C, the measure of angle CAB, that's what the little m means, the measure of angle CAB plus the measure of angle BAD, so those are the two parts, are equal to the entire angle. That's going to be angle CAD. All right, so in summary, an angle bisector is something that kind of chops the larger angle into two equal pieces, cuts it equally in half. All right, so ladies and gentlemen, those are our 8 main ideas. In the next few videos, we're going to go over some actual examples that include algebra and using these definitions.